Good day, students and viewers. As you can see, our topic today is reference angle, and the course is Maths 103, Trigonometry and Coordinate Geometry. In today's video, we are going to look at reference angles, and we look at the following diagrams. So this is the Cartesian coordinate. Let me draw 2 of them. Of course, we are going to draw 4 for each of the quadrant. Now, if theta is in the first quadrant, suppose theta is in standard position in the first quadrant. So this is the first quadrant. This is the second quadrant. So theta in the first quadrant is looking like this. And so everything is the same. The reference angle for each of the following angle, for each of angles in the first quadrant is its own reference angle. But coming to the second quadrant, here is the second quadrant, this is the first quadrant, here is the second quadrant, theta in standard position. If this is theta, but theta in this second quadrant, here the second quadrant is talking about 180. Now, the reference angle in the second quadrant, phi, is equals to 180 minus the given angle theta. Now let's go to the third quadrant. In the third quadrant, somewhere here, theta in standard position has its own reference angle. This is equals to, it is theta, the reference angle phi is equals to theta minus 180 degrees. The reason here in the second quadrant, if you subtract 180 from, if you subtract theta from 180 degrees, you are going to have a positive angle, and that is the target, because the highest theta can reach is 180 degrees in the second quadrant. If you remove the given theta from 180, definitely you're having a positive angle. And here, because the highest theta can reach in the third quadrant is 270 degrees. Now, if you subtract 180 from whatever angle you have in the third quadrant, because it is greater than 180 but less than 270 degrees. Whenever you subtract 180 from the given angle, you are left with a positive angle, and that is the meaning. Now, let's go to theta in the fourth quadrant. Theta in the fourth quadrant, theta in standard position in the fourth quadrant. So the reference angle for theta is going to be, the highest theta can reach is 360 degrees. So now you have 360 degrees here minus the given angle, which is theta. You are going to have a positive angle. And here with us is an example to find the reference angle. The example is saying, find the reference angle for each of the following angles. And the angles are given in A, 68, 120, 250, and 315. Now, to find the reference angle for these angles, for 68, you check in which quadrant is 68 falling. 68 degrees is falling, I think, is falling in the first quadrant. In the first quadrant. It's in the first quadrant. And so, the reference angle, phi, for this theta equals to 68 is the same thing as 68 degrees. So in the first quadrant, every angle is its own reference angle. There is no distinction between an angle and its own reference angle. Coming to the second quadrant, second question, we have 120 degrees. So 120 degrees, this one lies in the second quadrant. Why did I say it lies in the second quadrant? I said it lies in the second quadrant because it is greater than 90 but less than 180, so in between. So it has to lie in the second quadrant, and that is here. First quadrant, second quadrant. So theta is lying between here. So this is theta in the second quadrant. I mean, 120 is lying in the second quadrant. So the reference angle, the reference angle phi is equals to theta is equals to 180. Remember, in the second quadrant is 180 minus theta. And what is our theta? The given theta is 120. So the reference angle is equals to 180 degrees minus 120 degrees. And this is exactly equals to 180 minus 120. This is 60 degrees. This is equals to 60 degrees. Now, let's go to the C part of the question. The C part is saying 250 degrees. Where is this lying? 250 degrees, this is greater than 180 but less than 270. And definitely this lies in the third quadrant. So this falls in the third quadrant. And so what is happening? What is the reference angle for an angle in the third quadrant? So the reference angle phi in the third quadrant is equals to the given angle theta minus 180 degrees. And the given angle theta is 250 degrees here. So now this implies phi is equals to 250 degrees minus 180 degrees. It means phi is equals to 2, that is, I think when you subtract, you have 70 degrees. And that is the reference angle. Now, coming to the D part of the question, you have, the D part is saying 315 degree, meaning theta is given as 315. To find the reference angle for theta, you simply say this is falling, I think, in the fourth quadrant because this is greater than 270 but less than 360. So it is falling in the fourth quadrant. This one also falls in the fourth quadrant. And so the reference angle phi in the fourth quadrant is equals to 360 degrees minus the given angle theta. And this implies that phi here is equals to 360 degrees minus the given angle. The given angle is 315. So, and the answer is going to be 45 degrees. And again, we have another yet interesting example that one may like to actually solve. But to solve that example, we need to use a calculator actually for people to understand. Now, suppose that the given angles are greater than 360 degrees. How do you find the reference angle? To find a reference angle for an angle that is greater than 360 degrees, you have to subtract successively a multiple of 360 degrees to get the reference angle. Whatever angle is remaining, you check in which quadrant it is falling. If it falls in the first quadrant, that is the reference angle. If it falls in the second quadrant, then you repeat the process we have just concluded now in the previous example, that is example 5. Now, let's solve this. Question A, we have 723 degrees. Now, if theta is 723 degrees, so you have 723 degrees, but this is the same thing as saying, okay, now you pick your own calculator and just say 723 divided by 360 degrees, the answer is 2 point something. So you have 2 whole number times 360 degrees, and then plus what is the remainder. So you say this is equals to, and then minus the whole number 2 you have gotten. So this is it, and press equals to. So 723 divided by 360, this is equals to 2. This is equals to the answer, and then from the answer you subtract the whole number 2 we have written, and this is equals to this. So when you subtract and then multiply the answer by 360 degrees, the answer is 3. So this is plus 3. After subtracting this product, and so this is equals to what? So here you say phi is equals to 3 degrees, because this is your theta now. This is your theta. It implies that theta is equals to 3 degrees. The remaining after the remainder after subtracting a multiple of 360 degrees. 360 degrees here happens 2 times, and the remainder is 3. So you pick the remainder and say it is equals to theta. But this remainder 3 degrees lies in the first quadrant because it is not up to 90 degrees. And therefore, in the first quadrant, every angle is equals to its own reference angle. That is it. So we go to example B. Example B is saying 2265 degrees, but this is equals to, so you say 2265 divided by 360, that is equals to 6. So you have this is equals to 6 times 360 degrees, and then plus the remainder. So you just say, okay, from the answer minus the whole number 6, and this is equals to 0.2916. Then the answer also times 360 to get your remainder. So the remainder is 105 degrees. So now it implies that theta, the remainder is equals to 105 degrees. So 105 degrees actually, because what we're calculating is in degrees, so we need to carry the, we need to carry degrees along. Now, but what is happening here? We repeat the process above. Theta is given as 105 degrees. So theta is falling in the second quadrant. So this falls in the second quadrant. It's falling in the second quadrant. And what is phi now? The reference angle we are looking for. Therefore, is equals to 180 degrees minus theta, and theta is just 105 degrees. So 180 minus 105. So 180 minus 105, I think this is 75 degrees. So the reference angle for 2265 degrees is equals to 75 degrees. Now we go to example C, and then maybe from example C we close the video, and the example D will be left as an easy exercise for the reader or the viewer to verify. So for C is 3460 degrees, but this is equals to, so you write 3460 divided by 360 degrees, this is equals to 9. So you have 9 times 360 degrees, and then plus the remainder. You say, okay, the answer minus 9. You remove the whole part, and then multiply the answer by 360 degrees to get your remainder. So I have 220 degrees. So this is it. Now, so it means we are taking the remainder. And so theta is equals to 220 degrees. But theta equals to 220 degrees lies in the third quadrant, because it is greater than 180 but less than 270 degrees. So this lies in the in the third quadrant. And since it lies in this third quadrant, so it means the reference angle for theta is equals to theta minus 180 degrees, and that is the rule in the third quadrant. So what is phi now? So phi is equals to, what is theta? 220 degrees minus 180 degrees. So 220 minus 180, the answer is going to be 40 degrees. So the D part will be left as an easy exercise, 2490 degrees for the reader to the viewer to verify. And you just say 2490, 2490 divided by 360. This is equals to 9 times. You just say, okay, minus 6, the whole part. So this is equals to 6 minus 6, and then times so you just say 2490 divided by 360 equals to 6.9. So you say 6 minus the whole part 6, and then the answer times 360. So this is equals to times 360 degrees plus 330 degrees. So you see the remainder here is your theta. So theta is equals to 330 degrees. So kindly find the reference angle for theta here. This is left as an easy exercise for the viewer. Thank you very much.